7th? It's already the 7th.
It's the 6th.
It's not the 7th. Huh? But it's Wednesday today. Huh. Okay. March. And I've been feeling like today's Thursday. Like since yesterday, I've been feeling like today is gonna be Thursday. Okay. All right. Jeez. Oh, it's so bizarre. So, yeah, I'm thinking tomorrow's my brother's birthday. But anyway.
You would have wished me happy birthday
On the
7th.
wrong day.
You don't care about me. You don't even know my birthday. What kind of a brother are you?
Phew. Okay, anyway, no, it's something I noticed about something else. So yeah, log laws, logarithmic laws versus exponential laws, right? So let's quickly revise exponential laws. All right. And if we have an exponent or a base with exponent m multiplied by a base with exponent n, then the answer is what? The sum of the exponents are added. And if the numbers of the same bases are divided, then it's the difference of the exponents. If two numbers are inside a bracket and that bracket is raised to power n, then that's the same as the n raising each of the numbers in the bracket. That goes also for division. And where we only have a product of exponents is if a number with an exponent inside a bracket is raised to a certain number. And in this case, A and B are positive, and M and N are integers. All right. So now for logarithms, if we have log of x to power b, and all of this is to base a, this is the same as b times log x to base a. And this is where x is positive. And if we have again log x to base a, that's the same as log x divided by log a. Again, if we have log of xy to base a, that's the same as log x to base a plus log y to base a. And just refresh you, man. Come on. Yeah, I want to reload this page. Jeez, I'm not feeling the fan.
No, it's still hot.
Okay.
My skin is burning.
Yeah, it is unbearably hot. Okay. And computer is also hot. Sheesh. Your phone too? So all our tech is gonna get fried because of the heat, huh?
Mm-hmm.
Wow.
And to think I'm still gonna go into the heat so I can try to text it.
Excuse.
No, it's fine.
Excuse. Alright, and the last log law is for the division of x and y in the thing. So this becomes log to base x minus log, or rather to base a of x minus log y to base a. And in both these cases, x must be positive and y must be positive. Alright. I think the proofs, they can be for self-study. The proofs can be for self-study. Oh, that's why I wanted to do this, since I already have the Jamboard. Then I can reduce the number of things that are open. I know ChatGPT is probably eating away at my bandwidth. Okay, 155 minutes. This one is, how much is this one? 219. I'm closing off calendar, so I'm only left with Jamboard. How many megabytes is Jamboard eating? Oh, it's reloading. Oh, okay. At least the drill proves self-study. Alright. Now, we must determine the value of log 27 to power 4, and that is to base 3. So onward, example 12, we are working with the log of a number that is raised to a power. We're working with this law. So we must find what this expression 27 to power 4. And what's the size of the base? It's 3. Okay. So where do you think we can start? Oh yeah, thanks. 27, 4, 3. Where would we start?
We drop down
The 4 exponent.
Yeah.
So we can put it to the side, and then it's 4 log 27 base 3.
Yes. And then
Okay.
divide by.
We can still do that for log 27 as well. 3 times 3 is 9 times 3 is 27. So that becomes log 3 to power 3 base 3. Like that, right? And that means if we do the same process, we can have 4 times 3 of log 3 to base 3, and that gives us 12, because log 3 to base 3 is the same as log 3 over log 3, which is 1. Alright. And then we're told of a special case. Okay, so what's the special case? special case is that if we have a log to base a of the nth root of x, then this is the same as log x base a over b. And in this case, x and b must be positive. Oh, okay. And this is because what?
I'm listening. It's because
Listening. I think it's because this here on the left hand side is the same as log base a x to the power 1 over b, right? And when we have x to the power 1 over b, we can transfer that exponent, and this then becomes log x base a over b, which equals the first case. And I think also another important thing to note is that with this, when we have a number raised to power n, this equals a to the power m over n. So this law from exponents is what feeds that. Alright. I think these are easy. We're not going to spend time on them. Okay. It is often necessary or convenient to convert a log from one base to another base. This is called the change of base. So let's look at change of base. So change of base, if we have log x base a equals m, then
x is equals to a to the power n.
X is a to power m. Alright, yes. Now I know. And now if we consider the fraction,
X base b.
Consider, yes, log x base b
over log a base b.
over log a base b.
And substituting x is equals to a base a to the power n.
X equals x base a to power m. Alright. Then
X base b over log a base b.
Then our first consideration, log x base b, as you're saying, over log a base b
is equals to log a to the power m base
b
over log a base b.
Log a base b. Let me just write that neatly so it doesn't look like I use my feet to write it. Or my left hand.
Can you write with your feet though?
I could if I tried. Probably terrible.
The people who can.
Yes, there definitely are people who can change. But don't write on my floor.
It doesn't show.
It's gonna show when I sweep. Let's pay attention. So when so from this we can take the m as a coefficient of the log, and this just becomes m times log a base b over log a base b, and that's m times 1, and this means log x base b over log a base b equals the same as log x base a. Oh, but doesn't this kind of look like proving this other log law? This one here.
Sorry.
Yeah, it kind of looks like we're proving that one, doesn't it?
It does. Well, it is. Well,
It
we
is.
are.
We are, yeah, we just did. And there are special applications. So applications special and not Google Play applications.
That was not funny. It's not funny. No, it's I5.
I just remember when my teacher did say that there was a girl whose name was Sonia and we were studying the eye, and there's a part in the eye called cornea.
Yeah.
And he says, we're now going to look at the cornea. That's Sonia. And I'm like, oh, but say why?
That was unnecessary.
I know.
It's
Oh my
still
God.
necessary.
I can't believe I just remembered that. Anyway, special applications, next page. If we have log x base and it equals log x to base x, okay, over log.
No. It's...
Hmm?
Oh, okay.
Yeah, the special applications. I want to zoom in on here. Yeah. If we have this, then log x base a is the same as 1 over log a base x. Huh. So this is kind of like a reciprocated type of thing.
Mm-hmm.
So I'll just put there, it looks like a reciprocation. It's not a reciprocation, I'm not saying it is, but it looks like it. Reciprocation. Okay, and the second special application, also not from Google Play Store.
So I don't know who told you that was funny, but it's not.
I just feel the need to laugh at my own jokes so that I elevate my mood. Okay, if we have log to base a of 1 over x, this is the same as log to base a of x to power negative 1. And this, if we follow the other log, it's the same as negative 1 times log x to base a. This therefore means log of 1 over x to base a is the same as negative log x base a. So what does this one look like? We don't know. Can't think of anything as well.
It's not here.
Hmm?
It's not here.
It's not there. No? Okay. So let's apply the law change of
No,
base.
it looks like the one here exponential laws.
Oh, this one here.
Mm.
Oh yeah, it looks like negative exponent. Yeah, it looks like negative exponent. Alright, so next page. Alright.
So you know what's crazy?
What?
My toes don't touch the floor.
Really?
They don't.
So you don't, can you grip the floor like this with your toes?
I can. But when they relax, they don't touch the floor.
Wow, that's so random, but like, yeah.
It's cool.
Yo, remember this is being recorded.
Yes.
Yeah, so
You
people.
guys know that my toes don't touch the floor.
That's so weird, bro. To go on.
But Savannah, you made your application joke. Come on.
Oh my word. You are definitely, you must get 100% in the logarithmic section. There's too many jokes going on here. Do not.
It's a worked example 30.
It looks nah. Let's try it. Oh, worked example 13. 13, change of base. So log x to base a equals log base b of x over log base b of a. Alright. So we must show that log 8 to base 2 is the same as log 8 over log 2. So our right hand side is log 8 over log 2, and we can just start by looking at either left hand or right hand side, and whichever one you want to start with. Yeah.
It's all about preference.
And we can say the number 8 is the same as 2 to the power 3, and this gives us 3 times log 2 over log 2, and this is just 3. But our left hand side is equals to
Who said no? No.
is equals to okay, is equals to I will not
We forbid you. So you're forbidden from making jokes from now on.
for the rest of the day, no jokes, no jokes.
That's a lie.
But our left hand side equals log 8 to base 2, and we can also express 8 as 2 to the power 3. So 2 cubed, like that. Nejo, we can do that, miss.
Yeah, 2 cubed.
Okay, so then this gives us 3 times the log of 2 to base 2, and this is 3. Therefore, equals right hand side. Just like this. It underlines. But that wasn't a joke.
Secondly, please continue.
That wasn't a joke though.
I know it wasn't a joke.
Okay.
Next
Let's
thing.
do example 14. Worked example 14. And it's also the law of change in the base. And for this problem, we're told that A is log 2 and B is log 3. So we must express the following terms A and B in terms, or rather express
The following terms.
in terms of A and B. Express, what's the first one? Log 2 base 3. And the second one is log of 10 over 3 to base 2 in terms of A and B. Alright. So now, the first one would be log 2 base 3, which is log 2 over log 3, which is simply
A of B.
100%. You've got it right. Well done. Do you know that adverbarial?
Say, can you please make it less?
Okay.
You keep complaining, saying, we're recording, and yet you still make jokes. You say must be professional. You're still making jokes.
I won't make jokes. I won't make advert references from like way back when I was young. Okay, so the second one. Shush. So the second one is log of 10 over 3 to base 2, and this equals
log 10 over 3. Yeah. What? Log 10 over 3 over log 2.
Over log 2. That's fine. And how can we write log 10 over 3? We've got some rule there that speaks about... okay. I see where this goes. Remember that rule of negative log x base a is the same as log 1 over x to base a? Remember that rule?
Yeah.
I think we can apply it here. Do you see that?
Yeah.
Alright. So we're gonna have log 10 minus log 3 over log 2, and log 10 is 1, that is b, and that is a. That is our final answer. Alright, world, hold on. Should we do these examples? These problems, exercises?
Yeah.
Let's do them quickly. So we must convert log 4 to base 2 to base 8. How do we do that? We will say log 4 to base 2 is the same as log 4 to base 8 over log 2 to base 8, and this is the same as log to base 8 of 2 squared over log 2 to base 8, and that's 2 over log 2 base 8 over log 2 base 8, and that's just 2. That doesn't make sense. Okay, where did we lose each other here?
Yeah. Okay, I get over like 4 factorizers, 2 squared.
Yeah.
Right.
Okay.
And then maybe it's because I wasn't paying attention nicely. And then you bring down the 2, exponent 2.
To the other side, yes,
No,
of the log.
to the left side of the log. And then we're gonna have log. Okay. But say, why is it covering the whole log? Like the
Oh, because it can be also written like 2 over 1 times 1 over 1, which is just 2. Yeah, so that's where that answer comes from. Then we can do, this is A. Number B would be, we've got log 14 to base 10, right? Which we must change to base 2. And we'll start with log 14 over log.
So you're changing the 10
2 base 2, yeah.
to 2.
Yes, that's what we must do.
Like kanjani?
So we must do that by separating the initial base, making its log a denominator, and then the first one making it the numerator. So we're gonna have,
My question is, how does that work? How do we go from 10 to 2?
oh, okay, cool. Remember this part here. Change of base. It is often necessary or convenient to convert a log from one base to another base. This is referred to as a change of base, right? So we start out with an exponent. Okay, but in this case, we're just starting out there, right? And to change the base, we separate these two like so. So we'll take the log of this and make that a numerator, and then change the base. And we'll also make this its own log and make that a denominator and change its base.
It's so quite
I understand. It's quite confusing. But the long and short of it is that
we were given a base.
that we must convert to. So that gives us a b.
So that base is always going to be substituted in the place of b in the formula.
Yes. So where we have this b here,
And then,
we'll use the base that we're given to convert to.
okay, and then the a and x in the formula are going to be, what do you call the numbers on the side? They're going to be log of x and log of a.
Yes. So remember this one here? We were doing the word problem. Word problem. Yeah. 2 is the power to which 5 must be raised to give the number 25. So let's think about it this way. In order to get the number 14, we must raise the base 10 to a certain number, to a certain power. Right? So we don't know that. But now we must say, to get the number 14 with our base 10 that must be raised to a certain power, we want to change that base from 10 to 2. So upon changing the base to 2, we'll have 2 logs, one a numerator, the other a denominator, and we'll give them both a base of 2.
Okay. So it's just substitution.
It's just substitution for the most part, yeah.
Okay.
2 base 2, and this would be, whatever that is. We can quickly check for the, let's say, for the 7K. It's 2 8, ne? It's 2 8, ne? There we have it.
So we didn't have to substitute to break it down further.
Yeah, we don't have to simplify it to go any further.
Okay.
In the first one we could, because I mean the math does allow to simplify, but you could also just end here. Yeah. And then C would be how much? It was which page here? It was 7, 8. Yeah. Oh, we've already passed this part.
So it was 80. Maybe 90.
Actually 90, you're right.
I would guess. If only was that easy in my exam. Especially in physics by multiple choice. If you don't know the answer, you're trying to
And
like
you're
guess.
trying to guess, and then you guess
Yeah,
wrong and
you
you lose
lose
4 marks.
It's true.
It's true. Yo, you guys have it, I guess, tougher.
You lose 2 marks.
Yeah, our multiple choice were like 4 marks. I used to love the multiple choice of physics. Because then the 4 marks is worth it. You know, you do like a 4-minute calculation and you're like, there's no way these 3 could be 8. So.
Yeah, and you choose the one that's closest to your answer.
Yes.
If it doesn't make sense, you choose
Yes.
the one that's closest to your answer. Hopefully,
It's correct. So I used to love our multiple choice back in the day. Anyway, log of 4.5 to base 2. Interesting. How do we do this? So we'll have log of 4.5 equals log of 2 times 4 is 8 plus 1 is 9 over 2. And this equals, yeah, so it's like log 9 minus log 2. And since we're changing to base 2, hold up. My math's not mathing. Oh no, but I can still just have log 9 minus log 2. And to base 2, it would just be log 9 base 2 minus... Oh, maybe not that. I just want to try something else. Let me start with what I did. So I'll say log 9 over 2, which is log 9 minus log 2. And if we're going to do the base 2, it'll be log 9 to base 2 minus log 2 to base 2, which is log 9 to base 2 minus 1. But I want to try something else to see if I'll get the same answer. If we take where's that rule? The one linked to...
I don't want to see my mouth.
Hmm?
But I'm not going to see my mouth.
Oh no, I'm not asking you to.
I'm just saying I'm not going to see my mouth.
Yes, but we're gonna do maths together, right?
Yeah.
All
Let's
right.
say I'm not seeing my mouth.
Okay. Let me stop distracting myself by saying English. So what I want to say is, oh God, log of
It don't make sense.
9 times 2 to the power negative 1 That just gives me that. And it's... No, I'll just leave it at this. Let's just check the solution set quick. Something I'm not sure about. 468.
So what does it give you
Now
when you do 9 times 2 to the power negative 1?
That's a good question. That's like 9 times a half, so it's 4.5.
No, I'm not. You don't understand what I'm trying to say.
Oh, like with regard to the logs?
Yes.
Ooh. Right, so what I wanted to do with the 9/2 or 2 to the power negative 1 times 9, what I wanted to do with that was so that I'll be able to write the log 2 like that on the side. But clearly it's not giving, so it looks like, but the log 10 base 2, it's alright. It's from where? Okay. No, some things are amiss here. I'm not doing the log right. And if that something is amiss, then we must find it, right? So yeah, to change the log to 9/2 like that.
If we use the 9 multiplied by 2 to the power negative 1, like so,
Yeah.
wouldn't we get something like this?
Yes, we would. But remember that exponent is negative.
Yeah.
So it would give us that. So in essence, that is the same as that. Because remember, it's 9/2.
Yes.
Yes. So these two are the same rule. It's just that the exponents, they are different. So they give you different signs.
I thought maybe this would come this be.
Yes, it does. Think about it this way. So when you take...
At the end of the day, this part is this part for this.
So these two, I say they're the same.
Yes.
Just the difference in your exponents give you different signs there.
Yes.
Right?
Right.
And if you have 9 times 2 to the negative 1, it's the same as 9 divided by 2. So because of the negative exponent, you'll have a negative sign there. And because it's divided, you also have a negative sign there. What was that? There's no moisture on the table, right? Okay.
Was that like this?
Sounded like... I don't know what that sound was. Then, so let me write it down. So let's say we've got this, right? then according to that law, this applies. And it would mean as well as log x plus log y, and we're dealing with a negative exponent, so log of 9 times 2 to the negative 1 would be log 9 plus log 2 to negative 1, and then we take that exponent, so it becomes log 9 minus log 2.
Yeah.
All right,
Same.
so they are the
So
same.
that's the answer.
Yeah, so I'm just, yeah, we must now find what it means to change this to base 2. So we know that log of 4.5 is the same as log of 9 over 2. And, okay, I'm just trying to recall the answer as log 9 is 2 minus 1 over. So remember, this was the answer, right? I want to find out how this log 10 to base 2 was derived. Could be hold up, in the change to base method, change of base rather, the answer comes from log x base a is the same as log x over a different base divided by log a over that same base. So for this one, what it could mean, so by default this is base 10. So if we're gonna change these bases, then this would be
It makes sense.
log 9 to base 2 over the log of what? 10 to base 2. Minus log of 2 to base 2 over log 10 to base 2. And that's why the final answer is log 9 to base 2 minus 1 over log 10 to base 2. You get it? Alright. I just want to write it out neatly so that it shows what we're working towards. So log 9 base 2 minus log 3 base 2, 10 base 2, which is log 9 base 2 minus 1 over log 10 base 2. Alright, so this is just a side note. I'll just demarcate it like that. Okay, so this problem, I think we needed to just be conscious of the fact that these are to base 10. Naturally, if we're doing log, it's base 10. Unless you're doing, there's a different type of logarithm, which is to base e, but we did that in engineering maths, so I'm pretty sure it's for maths beyond the matric syllabus. unless you're writing an independent paper. Alright, to the left, to the right. Do not sing along. Next question is number D. Why? 8 base 2 to base 8. To base 8. Alright, so we will have log 8 base 2, which is the same as log 2 cubed to base 8 over log 2 to base 8. And this equals 3. I think that's the final answer.
I guess so.
Because
Cancel out and then you're left with the 3.
we're left with the 3. Because what happens is, okay, maybe let me not start here. Maybe let me start here. So if we're gonna convert these to base 8, convert to base 8, and then here make 8 equals 2 cubed, so we'll have log 2 to the power 3 to base 8 over log 2 base 8, and this equals 3 over 1 times log 2 base 8 over log 2 base 8, and that just equals 3. It's sharp. And number E, we'll have log x to base y, and we must change everything to base x. That means we will have log x to base x over log y to base x if we convert to base x, and this would mean 1 over log y base x, which is, rather let me say, here it's because log x to base x equals 1, and therefore log x to base y equals 1 over log y to base x. You see this one, what it looks like? It looks like this one here. Where is it? Remember where I said it looks like a reciprocation?
Yes.
You see it looks like that.
Yes.
Alright. So that means in a test or exam, if you see something that looks like log 2 to base 5, and they say, or something that looks like 1 over log 2 to base 5, then you can just flip these two around and say that equals log 5 base 2. And check. So it's just a quick neat trick to know when you're in a test or exam. I think that's great. And then lastly, we have log 2x to base 10, and we must write to base 2, right? This means log of 2x over log of 10, both to base 2. So this is conversion to base 2, and then that means we've got log of 2 base 2 plus log of x base 2. All this is over log of 10 to base 2. And that just gives us 1 plus log x base 2 over log 10 to base 2. All right. Here. Yeah, there we go. Okay, so all right, so we've done that. You want to do calculator use now? Okay, at least we'll be engaged. I know it's hot when it's really difficult to focus, but
I'm sleepy.
yeah, I know.
Last night I slept late doing my brother's project.
What project was this?
I had to make an elevator.
An elevator. Okay. How did you make it?
2 rectangular cardboard. Put them like this, and then had the square ones like this. Put kebab sticks going up like that, and then we made the box
Of the elevator.
of the elevator, and we made 2 holes.
Okay. On the small box that goes inside the 2 rectangles. Okay.
And then plugged it inside those 2
Oh, so you just slide the box up and down.
Yes.
That's pretty simple.
And then put a thread of wool. We made that thingy out of
The pulley
yeah, something like that.
out of the cotton.
It was we cut a circle box like this, and then had a smaller circle inside. Put it, so it how to explain it?
Did you take a video?
No,
Why not?
we're too tired to take a video. We did it like late at night, around 1. So we finished God 2.
You.
Yeah, because this guy told us, oh no, Mem wants the project tomorrow. And we're like, what?
And he didn't say like earlier. Was he playing during the day?
He was at the library.
Oh, shame. But yeah.
So yeah.
Okay. Use the calculator to determine the following values and correct your 3 decimal places. Alright, so ln is a different type of log, right? Or rather, it's log to base e.
What? What is
See,
a different type of log?
It's not a different type of, it still works the same, but you see there's log and then there's ln and then there's log box.
So this is ln.
ln. If it's ln,
Is it ln?
let me see. Yeah, that's ln. That's not a logarithm that we're gonna use. So we're gonna focus on this one here,
That one, yeah.
that one, because this one is the same as this, right? So that ln is log to base e.
Okay.
Yeah, but don't worry about that because that's what we had. Yeah, so we had to learn this for our first math classes in engineering. So anyway, you can just punch in the log of 9 and see how much that gives us.
Like so.
Yeah, 954.
Is
Then-
0.95.
Yeah, 954. Then log of 0.3 is how much?
You know, my principal in primary didn't have teeth. Like his typewriter teeth were gone. It's negative
0.552. Okay.
Yeah.
And what's the log of 3/4?
Log of 3/4 equals negative
1.25.
Yeah.
And what's the log of negative 2?
Log of negative 2.
Yeah, boy.
And you ate my bakus and meat with me. Error.
It says error, right?
Yeah.
Okay. So you remember from our log laws, the laws of logs, laws of logs, laws of logs. Where's that one? Where is that one? Remember, sorry. Oh no. Remember, there's a part that says x must be positive, right? Yeah. So that's exactly why in the last calculation we did log of negative 2 got undefined. Okay, fine. That's why we got undefined. I think also when you look at this, so let's say we've got log x to base b, right? X is positive, and I think when x is smaller than 1 but greater than 0, then log x to base b is negative. Yeah, and it's positive when x is positive. So I think that's what our calculator use is also giving us hints of. Yeah. Inverse logarithmic function. We're going to do that. Alright, so use the calculator to determine the following values correct to 3 decimal places. So log x is 1.7. So this is what, for example, 16. So, and this is on page 80. Alright, so log x is how much? 1.7. We must find the value of x, right? How do we find that? We have to use the inverse log function on our calculator. I did. Let me see. Bani uzo bona gucci. Esiro papa ya mafuta. Ageko.
So you can't take anything serious, but it's 38.
Yo, do you know that video? Of the kids singing Ageko or what? Oh my god, I'll need to look for that and watch it. Okay, so I think this is going to require us to do some little bit of math. So let's try that. How do we move from log x to exponents?
From log x.
Yeah, to exponents. Base 10. Isn't it? Let's say we've got log of a Are you going to switch pages? Yeah, if we've got log x to base a equals m, how do we write it as exponent? It's a to power m equals x, correct?
Yeah. Oh, yeah.
So that means for here, our base is 10. So 10 to the power 1.7 equals x. Therefore, what is x?
2,11.
119.
Wait, is this its second function? Let me see.
Which one?
It's 1,7, right? Oh,
Yeah.
found it.
Where?
The 10.
Oh.
It just didn't show it there.
Okay.
And
So
usually normally it does that.
it has like a yellow thing writing
Yeah,
on top of
it's
the
like
above the
something
butt.
like-
Yeah,
it's
yeah,
something
like
like
that.
this.
The inverse.
So that's what I was looking for.
Oh, okay. And then another word of advice. So there's two ways of rounding off, right? So in our answer we got 50.1187 ... right?
Yeah.
Remember that. So just call out the full number for me. I want to show you something.
50,187.
187.
1,187.
What else comes after? 233. Okay, 233. Right. So let's say this is it, man. If they say round up to 3 decimal places, normally we round up. So below, so 4 and below, you round down. 5 and above, you round up. Because between 1 and 9, 5 is in the middle. So from the middle, you go to the next number. But below the middle, you go to the number before. So if they say round to 3 decimal places, and your number is 5.1187, then to 3 decimal places, you know this is where you're going to stop counting, but you look at the number after. Is it 5 or above? If yes,
5 and above, you round it off to the nearest.
then you round this one to 9 to get to 9 there. But if you just cut it like that and make it 5.118, 50.118, that's called truncation. So that's the line upon which you truncate, cut your decimal. But then to round means you consider the number either before or after. Yeah. So that's just a reminder. Alright. Oh no. So we can remove these. Do you see how the eraser grows up when I move the thing? So let me doodle. So I want to start small. Now I want to go wild. Expand, yeah. Then the next number is log t equals 2/7. Is that correct?
1,931.
Oh yes, that is correct. So 10 to the power 2/7, which equals 1,931. And the last one is log of y is -3.
0,00. 0,
So it's 10
to the power negative
-3, so it's 0.00123. Yeah, that's correct. That is correct. Correct. It is correct. You say you want to study Bloemfontein. You are going to meet people who speak like this.
Yeah, the only good thing about that is that I can hear them when they cuss me, and I can cuss them back.
You don't have to take it personal. People always interact with others on their level of understanding the world. So if someone's never been taught to regard a other person as a human because of how they look, I'm not saying they're justified, but
No. All I'm saying is that I can hear you. And I can hear your mother with a teaspoon.
yeah. Anyway, so we've got log, this is work example 17 on page 81. So we've got log 5 base 2, and we must change that to, or we must find to 2 decimal places. So I think we can start off by changing the base, because our calculators use base 10. So here, if we change the base, we'll have to make to base 10, and we can have log 5 divided by log 2. Then on a calculator, we can work that out.
2,3.
2.3
2,3. 2,32. Yes, that's what I was trying to say.
Okay.
2,3.
2.
Oh, 3. Ow, what have I done?
Is it?
No, there's nothing wrong. My tongue is getting twisted.
3,322. 2,322. Yeah, I have to think about it to say it. Yeah, because there's so many 2's that come after the first decimal. Oh yeah. Logarithms. Oh
So
my
have you
word.
ever watched Ridiculousness?
I think I may have seen 1 or 2 parts of one episode.
You didn't like it?
It doesn't call to me, but
No.
if I find it playing, I'll watch it.
I'm just there for people getting hurt.
Ah. Hey, that's why it doesn't call to me. Like, why would you wanna? Okay, maybe now I'll watch it.
But sir, not so long ago, you were laughing at a lady getting lifted by a door.
Yeah, that's what I'm saying. Maybe now I'll think about it different, because, I mean, doing my workout, for example, out 4, and that's kind of like,
It's funny.
yeah.
It can be funny depending on the setting and the time.
And the time, yeah, not happening.
Yeah.
Alright, so
Let us proceed.
2-9. Okay, I want us to use the next 10 minutes to find maybe these 6, and then maybe do these 6, and then we move to the finish off today with the graphs. Yeah?
Cool.
Awesome. Number 1A is log 3, ne?
Okay.
And we must find that with a calculator.
0,477.
Great. And then log of 30 should be 4,777 something.
1,477.
1 comma. Oh yeah, that is correct. 1,477. That means log 300 is 2,477 something. Ne?
Yeah.
All right. Okay.
And then we have
666. It's how much?
negative 0,180.
Alright. So I tried drawing a 0 there, but it turned out to look like a heart. I didn't make it
Next
intentional.
page.
It's next page. Log of quarter.
Oh, it's a cute heart though.
It's like round, looks like a apple. Or an orange.
The one that. No, it's an apple.
Apple. Log of 1,4 is negative how much? 0,
1,4.
ah.
0,146.
Wait, how much did you do? 1/4. A quarter, yeah.
What do you want for? Negative 0,602.
72.
Negative 0,602.
Oh, 602. My mistake. 602.
852.
And then log of 852 is equals to 2,93. Okay. So, are you noticing that with a log, if you have 2 digits like this, then the first decimal is 1. If you have 3 digits like that, the second decimal is 2.
Mm-hmm.
So how it works is log 1 to base 10 is 0. Log 10 is 1. Log 100 is 2. Log 1,000 is 3, and so on. Ne?
Yeah.
So that's just for your reference. Then let's do number 2. To calculate the value of x. First case, it's number 2. A is log x equals 0.6.
Which is 3,
So 10 to the 0.6 is, that's how much?
3,98.
3.98. Alright, good. B, we've got log x is -2, so 10 to the -2 is x, which is 0.012, 0.1. C, we've got log x is equal to 1.8. Therefore, x is 10 to the power 1.8, which is how much?
63,096.
0.96. Okay. And then log x is equal to 5. And x is 10 to the 5, so x is 10. 100,000?
Yes.
100,000 rands. E is log x is -5. X is 10 to the power -5, which is how much?
3,162.
3,162. And F log x.
That one is 0,3. 0,316. Sorry.
Okay, I thought that looked funny.
Yeah.
It's log x is -0.5, right?
Yeah, -1.5.
Okay. And it's how much? 0.3.
16.
Just 0, not negative. 0.316.
16.
Okay, cool. That makes a lot of sense. The last one.
Okay, it's much more believable.
It's a lot more believable, yeah. Yeah, that's actually the correct way to put it. Log x is 0.076. This means, which is how much?
1,191.
Alright. What comes after the 1?
2.
In that 1,191? Ah, okay. Alright. So now, let's get to the graphs. Okay. I like this number.
What?
This number.
1,1.
Yeah.
1,191. Oh, it has a 2008 date.
Besides that, 119 is like my birth date. So, I'm thinking of a tattoo. Yeah.
Okay.
Because I've been thinking what I'm going to ink next. So, now we're going to functions. Log and exp functions. Alright. We've got f of x equals 10 to the power x, and f of x, or is it f inverse of x here? is log x. So find the properties. All right. I can imagine a property developer or seller or someone who's in real estate looking for the houses that belong to f of x and does it find the properties out?
Yeah, I have a friend that is in real estate.
Is it?
Yeah.
Okay.
Maybe I should send them that. Find the properties of f of x. Let's see if you can find it.
See if you can find the properties of f of x. All right.
If they
So,
don't get the joke, that'd be sad.
do you think they would understand it? Did they do maths?
I don't know.
If they did maths, they'd probably get it. Then it would be funny to them.
Yeah.
Yeah.
If they didn't do that, that's just sad.
It would be strong.
It would be boring. Who knows? I might even end our friendship. Because what do you mean you can't end it? You don't understand it.
Why would you end your friendship over not knowing the properties of f of x?
First of all, if you did maths and you don't know what that joke means,
Okay.
that's
Then
just
it's a problem.
that's a problem. Then if you didn't do maths, I understand. It's like, oh, that's cool. You didn't do maths.
Okay.
You did maths late.
Wait, how do you have a friend that's in property or real estate?
I don't know. It just happened.
How much older are they than you are?
He was 20.
They're 20.
Or 20.
Oh, okay.
It's not that. Oh, it's not like a book one. Yeah.
Oh, so you guys were school friends in school.
No. Just met on Instagram. We just became friends on Instagram and started talking. And then we told him he was in real estate.
Okay.
Yeah. And that he's still in college and studying further.
All right. Next page. All right. So 10 to the power x. Right. Exponential functions. Oh no. That doesn't look straight. You do know the generic shape of an exponential function, right?
Mm-hmm.
So it
It's
always
a J.
it's a J, yeah. It's a J, and it intercepts the y-axis at the point 0, 1, and to it, the x-intercept is the x-axis rather is an asymptote. That's the point 0, 1. And let's just have the line y equals x. Alright, so determine the properties of function fx. So this here is y equals 10 to the x. Shape, it's an increasing graph. So as x increases, y also increases. Intercepts are 0, 1, where x is 0, y is 1. And then asymptote is the x-axis. So let's just put all of those down. F of x. Okay, so y equals 10 to the x. Only y-intercept at 0, 1. Then we've also got shape increasing. Horizontal asymptote. Asymptotes, okay, it's horizontal. And that's x-axis. And what else? Oh yeah, domain and range. So what's the domain? Set of x values so that
X is an element of real numbers. X is
an element of real numbers.
yes. X is
And the
basically X is just an element of real numbers.
numbers,
We have
yeah.
both
Negative and positive, but the y just keeps increasing.
yeah.
And then the range.
Range and Y is an element of real numbers and both negative and positive.
No, y is only positive.
What is that? Oh, I'm looking at the wrong one.
Yeah. Y is always positive. So for the inverse, we're gonna plot that quickly. It's also a J, but like a funny shaped J, right?
Yeah.
Funny situated J. Alright. I'm getting better at drawing these graphs, eh? Alright. And here this intersects at 1, 0. So our function is y equals log x. Only x-intercept at 1, 0. Is it increasing? Oh yes, it is increasing. So the shape is increasing. It's got one asymptote, which is vertical, and that asymptote is the which axis? Y-axis, yeah, definitely. And what's the domain?
The domain X is greater than 0 and
Yes.
X is an element of real numbers.
Perfect. You win. Perfect. And then what's the range?
The range Y is less than 0 and Y is an element of real numbers. No.
Okay.
Y is an element of real numbers.
Just the real number, right?
Yeah.
Alright. You win. Perfect.
Sticker.
Have you played Street Fighter before?
No, I don't think so.
Your male cousins didn't take you to play that. I thought you...
Well, we didn't have phones. We only had an Xbox.
No, but couldn't you go to Shop at Mama and play machine there for like $5?
Well, first of all, we're not allowed to leave the yard.
Ah.
Right? Second of all, my grandmother didn't have like a shop that had like a video game inside.
Oh.
Which would have been cool, but she didn't. So, and I think she would have made a lot of money.
You would have made lots of money. Boys find $5 to play that machine with all their time. All their time.
That'd be so cool. And they'd just be sitting there in a circle competing.
Yeah.
There, my pool house, they used to have it.
Has it?
Yeah. I don't know if it's still there now.
Wait, where's Pool House?
It's on fire.
In Pai. Okay.
What's the road? Is it Mandela Drive? No. Mandela Drive is the one in
Okay.
the one going down. The one you used to go to Zone 5. That's the road.
That's Nelson Mandela, no?
Is it Nelson Mandela?
Isn't it?
Isn't Nelson Mandela like this one?
Yeah, the
Like
police
Teachers
station.
Town? Yes.
Yeah.
And then Ojiga, and then drive straight by Nelson Mandela and turn left.
At
Takes
Circle.
you. Not at the circle. At the
There
circle,
by
you go to Plaza.
There by Mabitane, was 5.
Yes.
Oh, okay. Jeez, that's far. Oof, it's far.
So I know you don't have coordination. Eh?
Me?
Yeah.
No, I've got good spatial awareness, but I find other people might not have the kind of spatial awareness I have. So people would say north and they'll point that way, and I'd be like, but the sun rises that way, why is north that way? I know.
That sounds.
I know, that's why I say I often find when I talk to other people, they would always point a direction that doesn't make sense based on where. I always try to find where east is.
Yeah.
Unless I didn't understand you the first time, then I would.
You see where like mono the to be the RDP.
Yeah.
You turn left there.
Or to go up as if you're going to the barrel.
Oh no, sorry, I'm talking about right. Right.
To go down as if you're going to Kwenamlot or the
Yeah.
other parts of Zone 5.
That's Zone 5. You go down straight and then on your left.
And you're gonna
straight.
pass that road.
Yeah, go down and then you pass bus stop, you pass the passage, you pass and then you go down. You're gonna go down and up. When you go up on your left, there's a peach. It's this color. It's called Pool House.
Oh, okay. It's so frustrating, isn't it?
It is because you can't get that itch. Itchy. Like, say, no, you're triggering it.
Kum kum. On Facebook, they called it kum kum sound.
And it is. Couldn't you make that sound up?
But black people, black people, we are our own people, eh?
South Africa is its own world, bro.
We are
South
our own
Africa should
people.
be given its own earth.
I think we should have our own earth.
It'd be something so interesting, yo.
Yeah. Anyway, let's do this one. G of x. This is word example number what? 19. On page 84. So g of x is log x to base 10. Okay, just 20 more minutes and then I know you're tired. I'm also starting to feel a little bit annoyed by being in class for so long. But we're going to finish off the next 2 minutes with this problem. And we must reflect the graph about the x-axis to give a graph of h. Alright. 1.
It's funny how people say H.
Yeah, why do people say h?
Like, why are you saying H? H.
I've never called h h until I've had to hear someone say h. I'm like, wait, what? What's h?
H for horse. H for horse. And then I used to be in hostel, right?
Mm.
And then it was grade 5. And then they'd be like, can I call you DH? Can I call you DH?
Oh, hostel.
What do you mean DH? I said DH. It's the dining hall. It's the dining hall. DH. If you can't pronounce the H,
just say ha. Just say ha.
If you can't say the H, just say it in full.
Yeah, like dining hall.
Dining hall. The dining hall. That's where it ends. I want a DH. I want a DH.
DH. I always ask myself, why do people call it H?
I remember yesterday my little brother getting his H almost sounded like H. And my mom was like, what did you say? And then he's like, I said H. And then my mom was like, oh, I thought you said H.
Your mom was like, you're not gonna say H in my house?
No. No, in my house,
We don't say H. We don't do
you
that.
speak proper.
We don't do that.
Speak. Let us speak. Let us
Mara, we don't say H.
We don't say H. H
It's
is
so
not
funny.
allowed.
It's so funny.
This is embarrassing. Imagine you going to the university and you meeting top students.
People still say H even in university.
I know, kind of like
People who graduate cum laude. H.
no, but like in a professional workspace.
They are there. H. They are there. I've worked with them. Yo, bruh.
But I'm in the meeting and you say Heish.
The Zoom meeting with people in the US. Hey, guys will say it. Guys will say H. Trust you me. Okay, properties of H. But yeah, let's finish off and then we'll chat. Properties of H. H. Before I keep saying H too many times, I end up saying H. I don't want that. Use G and H to suggest a general conclusion. A conclusion. Alright, so let's first draw g of x equals log x to base 10. So we shall start with this. Cartesian axis. Do you know what's called a Cartesian axis?
Cartesian plane.
Cartesian plane, yeah. Why?
Oh no, I don't know why it's called.
So, okay, and it's actually a cool story about mental illness that I think a lot of people don't know about. But there's a man.
It's based on a mental illness.
No, but the story of how it came about has to do with someone who was afflicted by mental illness at some point in time in their life.
Okay.
So the guy was called René Descartes, a Frenchman. He was a philosopher and I think a mathematician. I forgot, but he was, back in those days, people would be like 7 things at once. Like Leonardo da Vinci was an inventor, engineer, what. So René Descartes, doctor and physio, what. So yeah, René Descartes was one of those guys. I'm not sure exactly what his professions were, but I know philosopher is one of them.
Yeah.
And I think in his life he had a bout with mental illness.
Yeah.
Like he lost his mind, and I think he journaled about his experiences before, during, and after his affliction. Then he bounced back and he came up with some of the most prolific philosophical concepts, including questions about self-awareness, like the famous quote of "I think, therefore I am." It's attributed to him.
Okay.
But the cool thing about René Descartes that he did, Descartes is written like this. So his name, check the screen there. René Descartes. Descartes.
Okay.
So he then, in one of his works in maths, I suppose, he came up with a way of mapping a dependent variable to an independent variable. So if I increase my horizontal distance, by how much do I increase my vertical distance? And can I do that with things laying on a flat surface or for vertical plane, etc.? And Cartesian planes are used almost everywhere today. For planes to navigate, for your phone to use GPS, for us to do maths, etc. Yeah. But yeah, he was afflicted by mental illness, I think. And yeah. Bounce back. Boom. So yeah, Cartesian plane. So on our Cartesian axis or plane, we shall have our graph. Maybe let me not draw it in green. Let me draw it in blue. So g of x is the blue graph. And h will be the green graph. So we're starting with G, not H, and definitely not H.
Definitely.
Right, so there's G of X. Log
so
X.
isn't it supposed to be along the y-axis? Like this part, isn't it supposed to be like along?
I mean, I could stretch it.
Next to it.
You mean like this? like that. And then we can say the page cut us off. You can say the page cut us off. I mean, it still works out. I mean, like, we can't draw here. Why? We can't draw here.
Please, let's continue.
Alright, so now we must reflect g of x about the x-axis to get a graph of h, and then we will determine the properties of them. So to reflect it, we will simply draw something that looks like g of x, intercept at point 1 is 0, but move in the other direction. Okay, we'll say Rene Descartes stopped us there this time around. And then we must discuss.
So do I close this?
Yes, please. Thank you so much. Now we must discuss.
This looks like a fish tail.
Like a?
Like a fish tail. So,
Oh yeah.
sorry.
It does. What for? It's not calculating.
No. It's my mom's scuff tea.
Oh yeah. You're sick of Pisces. So yes. Now we've got g of x and we've got h of x. So h of x is this graph here. Alright, so that looks so cool. That pin joy. And then we must find the properties of h. What is the intercept of h? Is that 1, 0, right?
1, 2, 0.
Yeah. What's its shape? Increasing or decreasing?
It's decreasing.
It's decreasing, right? Because as x increases, the value of y decreases.
Is it for h or for g?
Just for h.
X is increasing and y is decreasing.
Yes. So for each value we have of x where we increase, y, it decreases. But for the blue graph, for each value of x that we have increasing, y increases. So I'll just remove those colorful arrows. Very cool. And then, so we know the shape. We've got the intercepts. Oh, it is a function because it passes vertical line test. Okay, so we got that. What's the asymptote? What's the asymptote?
X is equal to 0.
At x equals 0. Okay, and what else? Domain and range. This is just for h for now, eh?
Okay.
Domain is a set of x values so that
X is greater than 0 and x is an element of real numbers.
also x is positive and a real number. And what about y?
Y is just an element of real numbers.
You win. Perfect. All right.
I've watched Mordecai and Rigby, so I know you win.
Mordecai and Rigby. That's the regular show.
Yeah.
Yeah, I like that show actually. Yo, in 2018 when I was working in Richards Bay, I would wake up, bath, and then as I'm eating, getting ready for work,
No, it's regular show.
watch regular show. And I'm going to work, kind of.
It's so sad how Pops died.
Oh, Pops dies. Wow, that's so sad.
Yeah, he met his other twin. It's like evil brother. Yeah, who was all black and stuff. And then, even though Pops overcame that dude,
Okay.
nah, he lost his life after the battle.
So he did defeat his opponent, but they
Yeah.
both died in battle. Sheesh.
Yes, and then somehow Mordecai got married and Rigby as well.
Mordecai finally gets a girl. He marries.
Yeah.
Okay.
And then I think he married CJ. And then
The cloud girl.
yeah.
The one with the moods. I don't like that girl.
I find that the relationship toxic. And then
Yeah, that relationship was toxic.
I miss Margaret. Is Margaret
The one who looks like Mordecai.
Yeah.
The red bird, but looks like Mordecai.
Yeah.
I thought she was a good match for Mordecai.
She was.
But she was
Besides the-
unavailable.
Yeah.
Besides what, right?
Girl, besides the fact that they actually look alike.
Yeah.
Besides that fact, they make a good match.
Yeah. That other one was toxic, guy.
Everyone sees Mordecai with Margaret for once.
And
in a
she
second.
changes the weather.
She starts raining.
She's
And
toxic.
gray
That
clouds
one.
everywhere.
Anyway, let's finish up.
Rigby also got married.
To the girl with the glasses.
Yeah.
Oh, okay. That one figures.
Yeah, and the kids were running around the park. Yeah.
Oh, wow.
Benson Crew appeared. It's cool.
And what about Muscle Man?
Muscle Man. The Muscle Man got married to Starla.
Oh, yeah.
Yeah, and
And
then
then
they
his
had
friend Ghost?
Ghost. I don't know what happened to Ghost, but he was there.
Okay.
He was there. No, he married. Is that girl a musician or something? Yeah. So
But
girl-
the adventures are trippy, man. And I think that shows an allegory about stoners.
Yeah.
Yeah,
What
the way
they
those
did
guys
was
live.
normal.
The way those guys live, they live like stoners.
Always eating.
And playing video games and working at a park. What's that, stoner vibes?
and to think how their experiences were like so irregular.
Yeah,
Find
like
themselves going to out of
to, like,
space. And then
that's
they meet
probably
this-
them eating a mushroom they shouldn't eat.
ish. And
Yeah.
they have weird dreams. Ning Ning Pops is having things coming out of his dreams, and all